Hey, good morning. Today, let's take a look at the review for our final here. Okay, number one, evaluate. Log base 4 of 107 round to the 10,000th place. So in order to do this, we need to use the change of base formula to evaluate a log. So it's the common log of 107 over the common log of 4, because there's no log base 4 in our calculator here. So we'll do common log 107 divided by common log of 4. Okay, so common log of 107 over common log of 4. So we get about 3.37 10,000ths place, so 0 or 1 actually. If we're rounding, it should be 1. That's the thousandths place actually, so I need 4 decimal places to be the 10,000ths place, so 0, 7. Okay, that's our 10,000ths place. Number 2, solve. Okay, so we have 7 plus 4 to the 3x minus 1 equals 30. Okay, so first we need to get the log by itself, or the exponent by itself. 4 to the 3x minus 1 equals 23. Next, we're going to switch this to log form. So log base 4 of 23 equals 3x minus 1. And now we can solve this for x. So we got log base 4 of 23 plus 1 equals 3x. Divide by 3. So what we're going to need to evaluate to get our answer is going to be log base 4 of 23 plus 1 divided by 3. That'll give us our solution. Now log base 4 of 23, this needs to be done using the change of base formula, common log of 23 over common log of 4, and plus 1 to that, and then divide by 3, and that will give us our solution. So let me do that. Common log of 23 over common log of 4, and then add 1 to that, divide by 3. So our solution, 1.0873. Number 3, solve. So we have x over 4 minus 7 over x equals 3 over 4. Okay, so we're going to need to do our LCD, our lowest common denominator, which should have factors 4x. So to do that here, I'm going to multiply by x. Do that here, I'll multiply by 4. Do that here, I'll multiply by x. We got x squared over 4x minus 28 over 4x equals 3x over 4x. And now that everything's over 4x, I can just do the numerator is x squared minus 28 equals 3x. And then I just need to solve this equation. This is a quadratic, so I need to set it equal to 0 and factor it to find my solution. So x squared minus 3x minus 28 equals 0. So I'd be looking for numbers that multiply to negative 28 and add to negative 3. Negative 7 and positive 4. This factors into x minus 7, x plus 4. So I have two solutions. I have x equals 7. I have x equals negative 4. And it would appear that both these solutions work. Okay, as long as your denominator is not equal to 0, then the solution works. So it would appear that both of these are valid solutions to our equation. Number 5, use the given function. Okay, so the asymptotes for this function. Okay, so this is a rational function. So remember the formula for a rational function, a over x minus h plus k, where the h is the horizontal shift and the k is the vertical shift. And remember what these graphs look like. They have an asymptote, they have another asymptote, they have a horizontal asymptote, they have a vertical asymptote, and then they curve like this. Okay, so depending on the formula, the horizontal and vertical shifts, it's going to change the horizontal asymptote and the vertical asymptote. So the horizontal asymptote is the one that goes left to right, and that one is always y equals k. The vertical asymptote is x equals h. So the horizontal asymptote, our k value, y equals 3, and that's because that's the equation for the horizontal asymptote that moves the horizontal asymptote up and down, so it's going to move it up to 3. The vertical asymptote is going to be at 6 because their h value is equal to 6. All right, that minus 6 in the denominator is going to move it over to the right by 6 units, which means our vertical asymptote is now over at 6. Solve the log equation. Log base 5 of 7x minus 3 equals 4. So first we change this to exponent form. So 5 to the 4th power is equal to 7x minus 3. So 5 to the 4th power, we got to see what that is. 5 to the 4th power is 625. So we got 625, 7x minus 3. Solving this for x at 3. So 628 is equal to 7x. Divide by 7. And we get about, well, actually, I should probably just leave it as a simplified fraction. Yeah, I'm just going to leave it. But you can, so you could say that our solution here is 628 over 7. Or you could say, you could round it to about 89.7. All right, either one of these is fine. The solution is not as important as the steps to get the solution. All right, number 8, write as a single logarithm, which means condensing it. So first we have to use the power property, put all of these back inside as a power. Okay, so this is common log of a to the 4th minus common log of b to the 7th minus common log of c squared. All right, now we can combine them into a single log. So common log, and any of them that are positive will be in the numerator, and any of them that are negative will be in the denominator. So the a to the 4th is positive. Okay, but these are both negative, so they're both in the denominator, b to the 7th and c squared. So this is our answer, common log of a to the 4th over b to the 7th times c squared. $35,000 is deposited into an account paying 1.2% compounding continuously. Find the balance in the account after 20 years. So the compounding continuously formula, A equals P times E to the R times T. Okay, so A is the final amount, P is the principal amount, which is 35,000. E is Euler's number, R is the rate as a decimal, so 0.012 would be 1.2%. T is the time period, so 20 years. So if A is equal to 35,000 times E to the 0.012 times 20. Okay, so I just need to put this in the calculator. So E, where's my E button? There it is. E to the 0.012 times 20. And then multiply that by 35,000. And we get this is about 44,000 $493.72, approximately. Number 10, solve. Okay, so to solve this, we just square root both sides here. Don't forget, when you square root both sides, you get a plus and a negative answer. So plus minus the square root of negative 24. So we do need to simplify the square root of negative 24. So 24 has factors 4 times 6, and you can take the square root of 4. However, keep in mind you're taking the square root of a negative number here, so you do need to bring the I out as well. I is the square root of negative 1. So we have the square root of 4 and the square root of 6. Square root of 4 is 2. And then since it's negative, we need to take the I out. And then we still have the square root of 6 underneath the radical. So plus or minus 2i square root 6 is our answer for number 10. Number 11, solve. Okay, so we need to factor this. And since the a value here is 2, we need to factor by grouping. All right, so a times c, 2 times 2, so positive 4, negative 3. We're looking for two numbers that multiply to 4 and add to negative 3. And that is going to be, what is it? Multiplies to 4, positive 4, adds to negative. Oh, wait. Actually, that's not going to work because I don't think this is factorable, because we don't have anything that multiplies to 4 and adds to negative 3. So let's do the quadratic equation then. Negative b plus or minus the square root b squared minus 4 times a times c all over 2a. Okay, so a is 4, or 2, b is negative 3, and c is 2. Okay, so we have negative 3 plus or minus the square root of b squared, so negative 3 squared, which is 9, minus 4 times 2 times 2, all over 2 times 2, 2 times a. So we got 3 plus or minus 9 minus 16, which is negative 7, all over 4. Okay, so we got 3 plus or minus I root 7, I because it's negative, over 4. And this would be fine, I think. Okay, you could also distribute the division by 4 to get 3 over 4 plus or minus I root 7 over 4. This would also be acceptable. So both of these would be fine. Both of these would be possible solutions to write it out this way. Number 12, the square root of x minus 6 equals x minus 8. Okay, so we need to get rid of the square root, so we square both sides. So you get x minus 6 equals x minus 8 squared. X minus 8 times x minus 8 is what that is, which is x squared minus 16x plus 64. So x squared minus 16x plus 64. Okay, now we need to set this equal to 0 since it's a quadratic, so subtract x, add 6. Okay, so we get 0 equals x squared minus 17x plus 70. So we need to factor this. We're looking for numbers that multiply to 70 and add to negative 17. That's negative 10 and negative 7. Multiply these to get 70, add these to get negative 17. So that means this factors into x minus 10 and x minus 7. So we have two solutions. One of our solutions is x equals 10. One of our solutions is x equals 7. And these both work. 10 minus 6 is 4. Square root of 4 is 2. 7 minus 6 is 1. Square root of 1 is 1. Well, actually, that one doesn't work now that I think about it. So let's check these to see if they work. So substitute 10 into the problem. So 10 minus 6, so that's the square root of 4, equals 10 minus 8. So 2 is equal to 2. So this one works fine. Now if we plug in 7, we get the square root of 7 minus 6 is equal to 7 minus 8. So the square root of 1 equals negative 1. And that's not correct. The square root of 1 does not equal negative 1. That's 1 equals negative 1. So this one doesn't work. 7 is not a solution. Okay, so don't forget, you do need to check your solutions to see if they work in the problem. 7 does not work in the problem. All right, simplify cubed root of 81x to the 8th. So we're doing a cubed root, which means we need to have 3 of the same factor in order to factor something out. So let's see what 81 factors into. That is 9 times 9. And each of these 9s is 3 times 3. Okay, so this is the cubed root of 3 times 3 times 3 times 3. And x to the 8th, that's 8 x's. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so in order to make a number on the outside, we need 3 of that number on the inside. We have 3 of the same factors. So I can bring a 3 out. I can bring an x out. I can bring another x out. So I can bring an x squared out. So a 3x squared is what's going to come to the outside. Okay, and everything else is going to be on the inside, which is still a 3x squared. So 3x squared comes to the outside, and then underneath the radical, we still have a 3x squared. So 3x squared, cubed root of 3x squared. Number 14, write the equation for the inverse function. Okay, so if we write this as y equals x squared minus 5, and we switch the x and the y and resolve it, then we'll have our inverse function. So let's switch the x and the y, and then resolve this for y. So add 5. So x plus 5 equals y squared. Square root both sides. Don't forget plus or minus when you do a square root. So we get our inverse function, which is plus or minus the square root of x plus 5. Okay, so we need to write it the correct way. So f inverse of x is plus or minus the square root of x plus 5. There were 45,000 people living in a small town. The population started to decrease due to a mysterious and deadly virus. Given the function, by what percent was the population decreasing each year? So the factor here is going to tell us how much it's decreasing by. Because if we subtract this from 100%, it's telling us that every year there's 89.5% of the population left. So if I subtract that from 1, so 1 minus 0.895, I get 0.105. So this was decreasing by 10.5% every year. Number 16, factor. So this is a difference of 2 cubes. So that's our formula here. Same, opposite, always positive. So difference of 2 cubes. This is 2x to the third power, and this is 3 to the third power. So our a is 2x, our b is 3. So I just need to substitute it into this formula. So a minus b, a squared, so 4x squared, plus a times b, so 6x, plus b squared, so 9, and there we go. Now it's factored as a difference of 2 cubes. Number 17, find the remainder when, okay, so we can use synthetic division to do this. So we'll put negative 4 on the outside, since we're dividing by x plus 4, we'll put the 0 on the outside. Then our coefficients, 1, negative 4, negative 5, negative 8. This one comes down, and then we multiply them and add them. So negative 4 times 1 is negative 4. Add these is negative 8. Multiply them as positive 32. Add them is 27. Multiply them, negative 4 times 27 is negative 108. Add them, so negative 116. And that last number here is our remainder. Describe the end behavior. Okay, so end behavior has to do with two things. It has to do with the sign of the leading coefficient, and it has to do with the degree. Okay, so the degree here is odd because it's 3, and the leading coefficient is positive, okay, because it's a positive 5. All right, so if the leading coefficient is positive, the right side goes up. If the degree is even, both sides do the same thing. If the degree is odd, the left side is opposite of the right side. So the left side is actually going down. So our end behavior looks something like this. On the left side, so as x goes to negative infinity, the function also goes to negative infinity. The left side goes down. On the right side, so as x goes to infinity, the function also goes to infinity. The right side goes up. Okay, so down on the left side, that's what this means. Down on the left, whoops, actually I did that backwards. On the left side, this goes down, is what this says. On the right side, this goes up, which is what this part says. And that's our end behavior. Write an equation that represents a shift of 2 units to the right and 8 units up from the graph y equals 3 to the x. So a horizontal shift will directly affect the x coordinate. A vertical shift will directly affect the y, or the output of the function. So 2 units to the right, that would mean h is equal to 2, k is equal to 8 because it's 8 units up. So our function would look like this, x minus 2 plus 8. Number 20, if there are initially 5,000 bacteria in a culture and the number of bacteria triple each hour, the number of bacteria after t hours can be found using this formula. Okay, starting amount and the factor. How long will it take the culture to grow to 100,000? Okay, so we have 100,000 equals 5,000 times 3 to the t. We want to solve this for t. So first we'll divide by 5,000. So 100,000 divided by 5,000. So 20 is equal to 3 to the t. And now we can switch this into log form. So log base 3 of 20 equals t. All right, so common log of 20 over common log of 3, using the change of base formula to evaluate this, we will have the time period. So common log of 20 over common log of 3. So about 2.73 years is how long it's going to take. Mrs. Lopez surveys her class about their siblings. In the class, 55% of students have a brother, 62% have a sister, 40 have both a brother and a sister. What is the probability that a student has a brother or a sister? So probability of brother, wrong one, or sister. We can take the probability of brother, add the probability of sister, and subtract the intersection, the probability of brother and sister. So we have 55% have a brother, 62% have a sister, 40% have both. So 0.55 plus 0.62 minus 0.4. So 0.77 is the probability that a student has a brother or a sister. You could also use a Venn diagram to answer this if you wanted to as well, which would also work. We have a contingency table. What is the probability that a student selected at random is a junior given that the student is a female? So the probability of a junior given they're a female. So on the top, we want the probability of both junior and female. In the bottom, we want the probability of just being a female. Okay, so the probability of being a female, 16 over 32. Probability of being a junior and a female, 6 over 32. So we get 6 over 16 or 3 over 8. This is the probability of a junior given that the student is a female. 23, convert negative 260 into radians, so negative 260 degrees over 1 multiplied by pi over 180 degrees. So it's going to be negative 260 over 180 simplifies to 13 over 9. So this is 13 pi over 9, negative 13 pi over 9. $260 over 180. Yeah. Number 24, convert to degrees. So 10 pi over 3 multiplied by 180 over pi. Pi's cancel. 10 times 180 divided by 3. So this is 600 degrees. Simplify 5i times 5i, 25i squared. 5 times 5 is 25, I times I is I squared. But remember, I squared is equal to negative 1, because I is the square root of negative 1. So if you multiply these together, you get negative 1. So this actually simplifies to negative 25. All right, and that is it for our review here. Barely made it in time for the bell.